This is the third video for section 1.2 on data, sampling, and variations in data and sampling. So error and bias. The actual process of sampling causes sampling errors, like maybe the sample is too small. Factors not related to the sampling process cause non-sampling errors, like a defective counting device. And sampling bias is created when a sample is collected from a population and some members of the population are not as likely to be chosen as others. There can be incorrect conclusions drawn about the population that is being studied in this kind of case. So it's important that we look critically at the statistical studies we read about and analyze them before accepting the results of the studies. Common problems to be aware of include problems with samples, so biases. Samples must be representative, and samples that are not, that are biased, those give inaccurate and invalid results. Self-selected samples, those are responses only from people who choose to respond. Those are often unreliable. They either feel maybe really strongly, positively, or negatively, and so they might not be representative. Sample size issues, samples that are too small may be unreliable, though they may be the only option and you can still use them. You just have to consider that when that's your situation. Undue influence, collecting data or asking questions that influence responses. Like, don't you think that this is a good choice? That's leading people into answering in a specific way. Non-response or refusal to participate. The collected responses may no longer be representative of the population, as often people with strong feelings one way or another answer surveys, which can affect the results. That's like what we saw before a second ago. Causality. A relationship between variables does not mean one causes the other to occur, though sometimes people make that assumption. Self-funded or self-interest. Is the study impartial? Do not automatically assume one way or the other. You have to evaluate it on its merits and the work done. A misleading use of data, improperly displayed graphs, incomplete data, or lack of context. I know I said when we were making some graphs earlier, like you want to present your data in a way you want the viewer to see it. Sometimes people do that and it can be misleading and make people think something that may not be entirely true. Confounding, and that's when the effects of multiple factors on a response cannot be separated. So something else might have occurred that caused something to happen, and so you have to be careful that you're really looking specifically at the things that you think you're looking at. So a couple of examples. Are the following samples representative? Why or why not? To find the average GPA of all students in a university, use all honor students in the university as the sample. Is this representative of all students? No, most probably not, right? The honor students might have a different GPA overall than all students together. To find out the most popular cereal among young people under the age of 10, you stand outside a large supermarket for 3 hours and speak to every 20th child under age 10 who enters the supermarket. So is this sample every 20th child under age 10 at a large supermarket over a 3-hour span? That's probably fairly representative. Now, again, depending on where that supermarket is, you're going to have maybe a bias towards one thing or another. It's a little bit of convenience sampling, but maybe that's what you're looking for. And so maybe it is representative. What 3 hours do you pick? Is it when kids should be in school and so you don't get a lot of kids, or you only get kids who are homeschooled or kids who are sick or things like that? So it's not a bad place to start. So it's fairly representative, but probably not super representative. To determine the average cost of a 2-day stay in a hospital in Massachusetts, survey 100 hospitals across the state using simple random sampling. So that's pretty representative. In Massachusetts, so you're looking at hospitals across the state, simple random sampling to pick 100 of them, and then you find out that average cost of those 2-day stays. So that should be pretty representative. To find the average annual income of all adults in the United States, Sample U.S. congressmen. Create a cluster sample by considering each state as a stratum or group. By using simple random sampling, select states to be part of the cluster. Then survey every U.S. congressman in the cluster. Now, a lot of that's pretty good, right? The cluster sampling and the simple random sampling aspects, but are Congress people's salaries representative of everybody's salaries? Probably not. To determine the proportion of people taking public transportation to work, survey 20 people in New York City. Conduct the survey by sitting in Central Park on a bench and interviewing every person who sits next to you. Is that representative? No, it's convenience sampling, and that's rarely representative. If you're sitting in Central Park on a bench, are you near a bus stop, near public transportation? Are you far away from it? What are the people, what time of day? It's only 20 people out of all of the people in New York City. So this is not a representative sampling. Another example, a study is done to determine the average tuition that San Jose State undergraduate students pay per semester. Each student in the following samples is asked how much tuition he or she paid for the fall semester. So the first way is an administrative assistant is asked to stand in front of the library at one Wednesday and to ask the first 100 undergraduate students what they paid for tuition for fall semester. That's convenience sampling. A sample of 100 undergraduate San Jose State students is taken by organizing the students by names by class year and then selecting 25 from each class. So then that's stratified sampling. That's probably representative. So the convenience one is not representative, but it still might be useful. The second example, which is stratified sampling, is probably fairly representative. The third example, a random number generator is used to select a student from the alphabetical listing of all undergraduate students in the fall semester. Starting with that student, every 50th student is chosen until 75 students are included in the sample. So that's systematic sampling and is probably pretty representative because it comes from all the undergraduate students. The freshman, sophomore, junior, and senior years are numbered 1, 2, 3, and 4 respectively. A random number generator is used to pick 2 of those years. All students in those 2 years are in the sample. So this is cluster sampling. Is this going to be representative? Maybe people, in freshman year pay more because they have an extra piece of tuition or fees because they're first year students. Maybe, seniors pay less because they're out on co-op or something like that. I would be a little cautious about that one being representative. The last example, a completely random method is used to select 75 students. Each undergraduate student in the fall semester has the same probability of being chosen at any stage of the sampling process. So simple random sampling, it could be representative, but with simple random, you might end up with all freshmen or all part-time students or all, students doing, a semester abroad or something. So you might have to be careful with that one being representative. Sample variability. If we were to examine 2 samples representing the same population, even if we used random sampling methods for the samples, they would not be exactly the same. Just as there is variation in data, there's variation in samples. This is completely natural. However, if you look at 2 samples from the same data and you get very different results, it's time to reevaluate the data taking methods and the accuracy. You anticipate some variation, but if it's totally different or wildly off, then you want to double check and see what's going on. The size of a sample, often called the number of observations, is important. Small samples are sufficient for many purposes. In polling, samples that are from 1,200 to 1,500 observations are considered large enough and good enough if the survey is random and is well done. Many large samples are biased. For example, call-in surveys are invariably biased because people choose to respond or not. So that's self-responding or refusal to respond. People who feel really strongly might be the ones who are doing the calling in. So that's it for section 1.2. If you have any questions on any of this information from these 3 videos or from class, please don't hesitate to ask me. And here's my email if you want to send me an email.